And here is a typical decision maths critical path analysis exam question that involves Gantt charts and scheduling. So I'll just show you it all first, then you might want to have a go and I'll go through the answers. So firstly, part A is there's an activity network, do a forward and backward pass to work out the early event and late event time. So that's part A. And you get for that 4 marks. Part B is to state the critical activities, the length of the critical part for 2 marks. Part C is to draw the Gantt chart for this, another 4 marks. D and E are to basically try and schedule things, work out the minimum number of workers required and schedule those workers. Okay, so it's 15 marks in total. Typical, very, very typical exam question. So going back here, we want to, the network in the figure shows activities in the process. The activities represented by arcs, the number of brackets are the time in days to complete each activity. So we want to work out the early event time and the late event time. So the early ones are going to be the top numbers, and the late ones are going to be the bottom numbers as follows. And we're going to do a forward pass for the early event times and a backward pass for the late event times. Going forward, we're looking for the biggest number, and going backwards, we're looking for the smallest. So let's have a go. So we all start off with this one with 0 and 0, right? So when you get to here, what's the quickest time we could have got to here? Well, the only thing that must have happened before that is the A, which is 4. So that must be 4. All right, now go to B. What must have happened to get here? Only B, so this has got to be 6. The early time there has got to be 6. Let's go to C here. Now what must have happened to get here? Well, A must have happened and C must have happened, which is a total of 14. Okay, now let's go to D. How could you have got here? Well, A and D had to happen, which is 4 add 5, which is 9. So it's 9, or B and E had to happen. So 6 add 3, which is 9. So 9 has to be the number there as well. So it's 9 or 9 is our choice, and we chose, obviously, 9. Same thing. Okay, now we've done up to here. Let's go, let's maybe go this one here. How could we get here? Well, A, C and I have to happen, which would give us a total of 21. 4, 10 and 7 is 21. Or A and F must have happened, which would be 4 and 15, which is 19. So all of that must have happened to get there. So 21, we're going to choose the biggest number, and 21 is going to be the one we choose. What about here? How would we get here? Well, either A, D and G happen, which would be 9 and 2, 11, or the B, E and G get here, which is 9 and 2, which is 11. So that's got to be clearly 11. How would you get here? Well, B and H have to happen, which is 6 and 8, which is 14. How about here? Well, it could either be the 14 add the 5, which is 19, or the 11 add the 9, which is 20. You're going to choose the bigger one, so you're going to choose 20. And lastly, how did you get here? Well, it could be 21 add the 5 is 26, or 20 add the 4 is 24. You're going to choose the bigger 26. And now you're going to go backwards and start with that number 26 in the bottom. So you're looking back. So what time did you need to leave here in order to get here by 26? Well, 26 take away 4 is 22. As long as I left here by 22, I'd be fine to get there. What about here? Well, as long as I've left here by 21, 26 take away 5 gives me the 21. That's fine. Right, what about here? When did I need to leave here? 21 take away 7 is clearly 14, like that. How could I have got here? Well, it's either 14 take away 10, which is 4, or it's 21 take away 15, which is 6. We're going to choose the smallest number, which is 4. I have to have left there in order to not delay the project, okay? So that would be why that's 4. Let's go here. Either it's 21 take away 8, which is 13, or 22 take away 9, which is also 13. Okay, so I'm going to write 13 in there. What about this one? 22 take away the 5 is clearly 17. What about this one? It's either 17 take away the 8, okay, which is 9, Oh, actually, we need to consider this one first before we do that. So let's go to here. 13 take away the 2 is equal to 11. So how could we have got here? It's either 11 take away 3 is 8 or 17 take away 8, which is 9. So we're going to choose the smallest number, which is 8 here. Okay, so that is our, I'm going to rub these out, how I worked out the options. So that is our forward and backwards pass. And they're all our early and late event times. Okay, so now going on to the next part, it says determine the critical activities and the length of the critical path. Okay, the critical activities have a float of 0. So do you know what? I'm just going to list all the activities out. We've got A, we've got B, we've got C, we've got D, we've got E, we've got F, we've got G, we've got H, we've got I, we've got J, we've got K, we've got L, we've got M, and we've got N. And we could work out the float of each. The float of that's 4, take away 0. So the float of that is clearly 0. That's going to be critical. Okay. What about the float of this? It's going to be 8, take away 6, take away 0, which is going to be 2. That's going to have a float of 2. We should actually show these, so I'm going to rob that out. I should show my working for a float, in fact. So this is going to be 4, take away 0, which is 0. B is 8, take away 6, take away 0, which is 2. C is 14, take away 10, take away 4. So 14, take away 10, take away 4, which is 0. D is 11, take away 5, take away 4. 11, take away 5, take away 4, which is equal to 2. E is 11, take away 3, take away 6. So 11, take away 6, take away 3 is going to be 2 again. F is 21, take away 15, take away 4. So 21, take away 15, take away the 4, which actually gives me a float of 2. G is 13, take away 2, take away 9. So 13, take away 2, take away 9, which again is a float of, sorry, that should have been 2. H is going to be 17, take away 8, take away 6. So 17, take away 8, take away 6 is going to give me a float of 3. I, 21, take away 7, take away 14. 21, take away 7, take away 14 is clearly 0. J is 21, take away 8, take away 11. So 21, take away 8, take away 11 is going to be equal to 2. K is going to be 22, take away 9, take away 11. So 22, take away 9, and take away 11, which is going to give me a float of 2. KL, L is going to be 22, take away 5, take away 14. So 22, take away 5, take away 14 is going to equal 3. M is 26, take away 5, take away 21. 26, take away 5, take away 21, which is clearly 0. And N is 26, take away 4, take away 20. 26, take away 4, take away 20, which is 2. That should be N there. Okay, so the critical ones are clearly A is critical, C is critical, I is critical, and M is critical. So A is critical, as on the picture that I've already drawn. C is critical, I is critical, and M is critical. So that's our critical path along there. So going along here, what are the critical activities? Well, they're A, C, I, and M. So we would write in here A, C, I, and M. And the length of those critical activities is 26. So we would write 26. And I think the unit was about days, so we would write 26 days. Now we're asked to draw a Gantt chart for the process. So I'd firstly draw my critical one along the top, 0 to 26. So 0 to 26 as follows. Now A takes 4, it would be 4, then a 10, then a 7, then a 5. So it would be 4, then a 10, then 7, and then the 5, and they would be A, C, I, and M. And then all I'd have to do is I'd have to fit in my the rest of mine. So I'd have to fit in B. So it can start in 0 and goes up to. So it can start at 0, goes up to 8 like that, but it's 6 long, like that. And what I'm going to do, rather than do dotted lines, just this time I'm just going to shade that in to show that that is the float. So that is B. So I've done A, B, C. Now I need to go for D. Done this one as well. D starts at 4, could end at 11, is 5 long. So starts at 4, ends at 11, it's only 5 long, so it goes up to 9. And that's going to be D. So I've done A, B, C, D. Now I'm going to go for E. E starts at 6, ends at 11, is 3 long. So starts at 6, ends at 11, is only 3 long. So I've got a float there. And that's going to be E. So I've done A, B, C, D, E. Now I need F. F here starts at 4, ends at 21, is 15 long. So starts at 4, ends at 21, but is only 15 long. So would go up to 19. So it's got a slack float of 2 even. So like that. So that would be F. A, B, C, E, F, G. So G starts at 9, ends at 13, is 2 long. So starts at 9, ends at 13, is only 2 long. So that would be G, and that would be my slack there. So I've done A, B, C, D, E, F, G, H. Now I just need H. H is starts at 6, ends at 17, is 8 long. So starts at 6, ends at, I think, 17, we said. Is that right? Ends at 17, starts at 6, ends at 17, but it's 8 long. So 1, 2, 3, 4, 5, 6, 7, 8. And there's its, that there. That's H. Done I, and then we need J, K, L. So we need J, K, and L. So J, 11, 8 long to 19. So it goes 11 to 19. Hold on, let's go back to here. L is sorry, I've just done A, B, C, H, I, J. I need J next. So J is starts at 11, goes to 21, is 8 long. So starts at 11, goes to 21. Starts at 11, goes to 21, but it's 8 long. So it would only go up to 9, would only go up to there. So that's J. Now we need K. Going back to K here. K is this one. Starts at 11, ends at 22, is 9 long. So 11, add 9, but it goes up to 22. So it goes from 11 to 22, is 9 long. So it goes from 11 to 20. That's K, J, K. And this is the spare there. J, K. So I've done A, B, C, D, E, F, G, H, I, J, K, L. Just need L and I'm finished. L and N even, in fact. So L, 14 to 22, but it's 5 long. So L is 14 to 22, but it's 5 long. Okay. That's L. And I just need N at the end. Starts at 20, ends at 26, is 4 long. So starts at 20, ends at 26, I think, and it said it's 4 long. So So there we go. That's N. So there's my Gantt chart. I've got A, B, C, D, E, F, G, H, I, J, K, L, M, and N, all the way up to N, like I had done previously. So there you go. There's my Gantt chart for that. I've got those 2 and those 4 marks. Lastly, it says each activity requires only one worker and workers may not share an activity. Use your cascade or Gantt chart to determine the minimum number of workers required to complete the process in the minimum time. Explain your reasoning. It's just helpful. This isn't the answer, but to work out the lower bound. I just always find that helpful. The lower bound, if you add all these times up here, so 4 and 6 is 10, is 13, is 18, is 28, is 30, is 38, is 48 and 53, is 60, is 68, is equal to 77, is equal to 82, is equal to 86, and is equal to 91. So the lower bound for this, for me, it's just useful, is 91 divided by the length of the critical path, which is, we said, what, 26. So 90, if I did 91 divided by 26 on my calculator, what would I get? Will I get 3.5. So therefore I need at least 4 workers. I couldn't do better than 4 workers. So that just gives me help here to do that. So I've got to look along here and decide why 4 workers is good. Well, I could find a time where 4 things must be happening at the same time, and that shows me 4 workers are needed. So where along here would be the best choice for 4 things to be happening at the same time? Well, what if I chose this line here? I'm just going to do that line there. Imagine I chose 13, like midday on the 13th day. Now, what must be happening there? Clearly, C must be happening. F has got to be happening as well. That's 2 people I need. H can't be shoved along, so H must be happening, that's 3. J, well, I could shove J along 2. If I shoved J along 2 places, J would still be happening then, so I would need 3. And also I could shove K along, so it looks like I need 1, 2, 3, 4, 5 workers. So given that I found the time where I'm going to need 5, where 5 activities are going on, it looks like I'm going to need 5 workers. So what I could say is midday, day 13, 5 activities, so therefore 5 workers. That's what I could state as my answer without scheduling. I should state them, I should say it's C, F, H, J and K, i.e. C, F, H, J and K. I should state them. Now it says schedule the activities using the number of the workers you found in part D so the process is complete. So clearly I'm going to have the critical path along there. So I'm going to have the critical path. I think that went up to 26. So A was, it was 4, let's just look back at the original, it was 4, 10, 7 and 5. So it's going to be 4, 10 along here, 7 and 5. And they were activities A, C, I and M. So they were A, C, I and M. That was worker 1. Looking back here, I could have B starting there, so I could have B and then D. There's no harm in that. Let's look back here. Could I have B and then D happening after it? Yeah, absolutely. So I could have B and D next. So B is from 0 to 6. And then I could have D slotting in there, which I could do from 6 to 11. So I could have that from 6 to 11. That was B and D. E can't be moved along here, or F. So E and F are as they are. E and F have to be happening at different times and different to this. So I'm going to leave E and F currently where they are. So E is going to be starting at 6 and ending at 9. So E is going to be starting at 6 and ending at 9. And F is going to be starting at 4 and ending at 19. So starting at 4. Ending at 19. They were E and F. So let's see what else I could shove along here. G, well, I could have that slotting after any of these. So I could have it after E, or I could have it after D. I could have it after E, or I could have it after D in theory. So what I might do is I might move G along so it's 11 to 13, and I'm going to have it after D. So G is going to be 11 to 13. After D. Now just check back in my diagram. Can G happen after D? G can certainly happen after D. That's fine. So now I've done G as well. So I've done all of this. I've done this one, this one, this one, this one, and this one. H. Now H, I could shove H along 3 and have it after E. So there'd be no problem in that. So I could shove H along and have it after E. Now H is 3, 6, and 8 along. So I could have it after E for 8. So 1, 2, 3, 4, 5, 6, 7, 8, like that. So I could put H there. Now can H happen after E? Looking back at our picture, H, wherever it is, can it happen after E? It can happen after E. It doesn't depend on, E doesn't have to be done first, so that's fine. Okay, so going back to the picture here, we've done this one. J, where could J go? Well, J has the option from 11 up to 21. So J can go from anywhere from 11 to 21. So 11 to 20. It's going to have to go on its own because everything's already filled up. So it has to go from 11. You can go anywhere up to 21. But let's just check. J is 3, 4, 8 long. So I'm just going to just shove that there at that point. So that's going to be J. So I've done J as well. Now K, how many workers have we got currently? Let's just take a look. Got 1, 2, 3, 4. Got 5 workers there currently. Okay, so we've got to think of a place to put some of these. Now just think about it. I just had a thought. J, I could have moved it over by 2 and put J up here. So what I'm going to do is I'm going to put J up here like that. And as long as J can happen after G, and J can happen after G, that's absolutely fine. So that gives us a lot of space here. So we've done G, and we can go for K. Now I could do K between 10 and 20, 10 up to 20. So that I could do K from 10 up to 20. From here, from 10 all the way up to 20. There's no harm in that. So that's K. Going back here, I've done K. Now it's just about squeezing in L and M. So L can start at 14 and end at 21. Where could we fit L? Can start at 14 and can end at 21, and has got a slack of 3. So in theory, it could start at, is that 14 there? There's a 14, it's 1, 2, 3, 4, 5 long. So it's 5 long and it's got a slack of 3. So it could start at 17 in theory. Anywhere, I could have it in here, yep. So I could have it in here, starting at 17 and it's 5 long. So that was going to deal with L. And lastly, N. Well, N is 1, 2, 3, 4 long, and it could start at 20 with a slack of 2. So it could start at 20, so that would clearly go in there, and it's 4 long. and that is N. Okay, so I've used 1, 2, 3, 4, 5 workers. Have I kept all the dependencies? Well, clearly worker 1 is right. This is worker 2, this is worker 3, worker 4, worker 5. Let's just check these can hold. Does D depend on B? So going back here, D can happen after B, certainly it can. Can G happen after D? G can happen after D, it certainly can. And can J happen after G? Can J happen after G? Well, J's then, and it can happen after G, so that's absolutely fine. So I'm happy with that row. Can H happen after E? Going back here, can H happen after E? Well, there's nothing saying it can't. H can happen after E has already happened. And can L happen after H? Well, L is after H, so that's absolutely fine. And the last one, F is on its own. And can N happen after K? Can N happen after K? Yes, it certainly can, it happens. So here's our scheduling diagram, and it shows we've used 4 workers, and that's a possible schedule of the activities, so it's completed in the shortest time of 26. So I hope you found that useful. There's a 15-mark exam question that basically summarises the whole chapter.